Hi everyone. My name is Namrata Bandekar, and today I'm going to talk about video processing on Android. This is more of an intermediate talk, I would say, and you should have some knowledge of Android development. Also, this is going to be a talk about my experience tackling video processing on device for Android. To start off with, a bit about me. I am an iOS engineer at Oanda, and I'm also an Android tutorial member at raywenderlich.com. This is my 3-year-old puppy, Ginger. She looks really innocent, but she's quite a diva. And before I begin my talk, I just want to point out that I've uploaded my slides at this short URL, which just redirects to SpeakerDeck. And if you have any questions, you can, of course, ask them after my talk, or you can tweet them out to my Twitter handle with the hashtag DevFestFL. So let's talk about what do I mean by video processing. When I talk about video processing, I'm referring to the process of editing a video, which can include scaling, cropping, or overlaying data on top of a video. And in order to do these operations, we need to know some basic terminology. So let's go over that now. So you start off with a video file, or what is known as a container. A container basically represents the way the data is stored in the file. And popular container formats are MP4, AVI, or FLV. Then you also can separate the container using something called demuxing or demultiplexing. And that separates the container into two streams, the video stream of packets and the audio stream of packets. Both these streams are encoded, and some of the popular encoding formats that are used in videos today are H.264 and VPX, which was introduced by Google. So if you wanted to operate on the raw data, you would have to decode these streams. So for the video stream, it's decoded into video frames, and the audio stream gets decoded into samples. So you can decide based on which operation you want to do. If you were doing cropping of the video, that is reducing the resolution of the video, then you would have to operate on the decoded data. If you were just trimming the video in duration, then you can just operate on the video and the audio streams. You wouldn't have to decode the data. So once you have done your operations to manipulate the video, you want to encode both the streams, both the raw data streams back into the encoded streams. And then you want to multiplex them back together into the container. And at this point, you can decide to go with a different container format as well. And this whole process of demultiplexing, decoding, encoding, and then multiplexing the video is called transcoding. So let's look at some popular mobile apps today that use video editing. Snapchat is a very well-known app, and it's mainly video-based. There's also Instagram, which lets you upload videos and add special fancy effects to it. And there was Vine, which was made by Twitter. and it was a really big video hosting service, which was unfortunately shut down earlier this year. What are some of the common features in these apps with respect to video processing? So Instagram lets you add special video effects, which includes watermarking the video with text or images, as well as applying different filters to the video so you can make your video black and white. They also support merging multiple videos into one single file, and this is also known as concatenation. And some of them also support editing features like cropping the video in size or trimming the video in duration. So back to my story, I started working at a startup called Stage Name in 2015, and this was my second job. There were only 3 people working there, and I was their Android developer. They had a product called WeatherGIF, and this is what the app looked like. As you can see, it was a feed, and this was a feed of GIFs with weather data overlaid on top. And although I say it was a feed of GIFs, it was actually videos playing in a loop. What were the other features that I needed to implement for WeatherGIF on Android? So this is a short video of the app, and it shows that there was a view pager on top of the videos, and then there was also a share button on the bottom right for the users to share this video to their friends on other social media apps. So in order to implement the share feature, I had to do multiple video processing operations. The first thing was that all these videos were of different resolutions. So I had to scale them and then crop them to this 1:1 aspect ratio that you see here. Then I had to also watermark the video with the weather icon and the temperature text. And then for some social media apps like Instagram, they need at least videos of at least 3 seconds in duration. So I had to also loop a lot of these GIFs because most of the GIFs were less than 3 seconds. So at this point, the iOS WeatherGIF app was already made. And for iOS, Apple has this framework called AV Foundation, which provides a rich set of video editing features. So everything was being done on device for iOS. What did this mean for my Android app? This meant that there was no backend support for any of these video editing operations, and I had to do everything on device for Android as well. This was good in the sense that the Android app would use less bandwidth, and it would be faster and independent of the network. So I started looking at what kind of native support is available on Android for implementing these features. And I came across a few native classes like the media codec, which supports encoding and decoding for a bunch of different video encoding formats. Android also has media extractor, which lets you demultiplex the video. And they also provide a media muxer, which helps you multiplex the video back into the container. But as I looked further, I only found very limited native functionality on Android. And most of the features that I needed, the scaling, the cropping of the video, and watermarking, were unfortunately not available. and this was my reaction. So what next? I started looking at other third-party libraries which have video editing features, and I came across GStreamer, which was far too complex and too large to be included in my APK. I then came across something called FFmpeg. How many of you have heard of FFmpeg? Okay, so a fair number of people. So this is a very popular open source library, and why did I decide to go with FFmpeg? It is literally known as the Swiss Army knife for all things video related. It can do any video processing task out there. It also supports a lot of different filters. So in FFmpeg, operations like scaling and cropping are called filters, as well as very complex operations like applying convolution or blurring effects to the video are also supported. And it has a feature that can add subtitles to your video. So if you were making a media player app, this functionality would come for free with FFmpeg. So I started looking at how to use FFmpeg on Android. And I came across two ways to do this. The first technique that I discovered was to compile it as an executable binary and run it in a shell process in my app. And then I could pass commands to it to do all those various video editing operations. And the second method was to build it as a shared object library, or what is known as a .so file, and use the JNI, the Java native interface, to communicate between the Android code and the native library code. I decided to proceed with the first approach because it had the least friction. I wouldn't have to learn the NDK and everything. And I just wanted to try out how the performance was. So let's walk through that. This was my first time building any kind of C++ library. I came across a bunch of different dependencies that I needed to install just to build this. So I wanted to point that out. And for FFmpeg, I had to install AutoTools packages like AutoConf, which lets you configure your source code packages, AutoMake, which automatically generates make files, and libtool. So the first step for me was to download and unpack the NDK, which is provided by Google. NDK is the native development kit, and it helps you compile C or C++ source files with your Android code, which is in Java or Kotlin. Then I downloaded the FFmpeg source code from their GitHub repository. So FFmpeg provides support for a lot of different codecs, but popular codecs like H.264 and VP8 are not supported. However, there are other third-party libraries you could use for this, and you can integrate them with FFmpeg so that the compiled executable would support encoding and decoding these formats. So some of these libraries are libvpx and libx264. I also had to download the YASM library, which is an assembler for the x86 architecture. And the last step was to put all of these source code files, libraries that you had downloaded under the sources folder in your NDK directory. So FFmpeg can be configured to support whatever features you want it to support. So that means you can actually control the size of the binary that you compile, which is very, I would say, very good for Android, because then you can control the size of your APK. And this is an example of a very short configure script for FFmpeg. So let's go through each part of the script. So the first thing that's defined here are some environment variables for your build environment. So the target OS for Android would be Linux, and Arch just defines the architecture that you're compiling it for. So it could be x86 or ARM. And then you also define the directory where your NDK resides with the sysroot environment variable. The next thing that you see here is enabling and disabling different features of the FFmpeg executable. FFmpeg consists of 8 different libraries. So whenever you use an enable flag, it's including source code from that library into your executable. So for when I do enable decoders or enable encoders, it includes source from the libav codec portion of FFmpeg. And the last part that you see here is just enabling support for x86, that is YASM. And I mentioned this before, that FFmpeg doesn't support H.264 encoding. And for this, you could download a library called libx264 and integrate it with FFmpeg. And for that, you would have to include the enable libx264 flag in your configure script. And I just wanted to point out that you can control which encoders and decoders your FFmpeg would support. So you have that level of granularity. So once you're done with creating the configure script, it's finally time to build your executable. And you just run the make command. And then you have to literally wait for eternity for it to finish. And a lot of the times you run into errors and you have to start over again. So I think this graphic depicts the process pretty well. And then the compiled binary would be stored in the bin folder of your NDK directory. So once you have the executable file, you would place this file into the raw folder of your Android project. And now you need to be able to access or run this file in a separate shell process in your app. So you need to change permissions to run this. So this is an example code blob that I was using in my WeatherGIF app. And here I'm just copying the FFmpeg binary that I store in the raw folder into another folder, bin folder in my app. And then I'm changing the permissions to 755. So once you've changed the permissions, now you can run it in a separate process. And the next challenge is, how do you pass commands to your FFmpeg binary? For this, you use something called the process builder on Android. So for the process builder, you instantiate it by passing the list of commands you want to give to your FFmpeg binary, and you also specify the directory where your FFmpeg executable resides. And To start the process, you just call the start method on the process builder instance. And you can use the wait for method to wait till it finishes execution, and that returns an exit value. If this exit value is 0, that means the process was successfully executed. And a non-zero exit value indicates that there was some kind of failure. And since this is a shell process, you can just look up the shell process error codes to see what went wrong. It'll give you at least some kind of idea. So how do we pass these commands to FFmpeg? FFmpeg uses something called filter chaining. As we saw before, these operations like scaling, cropping, and watermarking are known as filters in FFmpeg. And when you chain them together, as you see here, it's called a filter chain. And this is another example of how I was passing commands to it in the WeatherGIF app. So here you can see that I am giving it the input file path, the file path for the watermark image that includes the weather icon as well as the temperature text. And then I'm scaling the video, cropping it to the 1:1 aspect ratio, and then I am overlaying the watermark image on top of each video frame. So let's talk about the performance with this method of executing FFmpeg as a separate binary in a shell process. When I would share any GIF in the WeatherGIF app, it would take forever, about 15 to 20 seconds, to share it to Instagram. And I think this GIF from Zootopia depicts it really well. And I feel the basic issue was that it was spawning a new process every time, and that would take up some, that would make the app less performant. So I started exploring the other way of building FFmpeg, that is to compile it as a shared object library. So in order to do this, you have to, again, download all the sources and put it in the NDK sources folder. And you also now have to write some wrapper classes in order to interface with your Android code. So you make a JNI project and you put that in the same folder as your NDK, because that's where the compiler looks for it. JNI is the Java native interface. And you also have to make an android.mk makefile where you define the variables for each of your modules. A module is a shared library that you're compiling. And in this case, here I'm defining the module name with the local underscore module variable. And the name of my module is video kit. I'm also defining what source files I want to compile into this module with the local source files variable. And then the local shared libraries variable defines the libraries that this module depends on, so the compiler knows. The other makefile that you have to include is the application.mk makefile in your FFmpeg code. This defines the variables across all the modules for your app. So here I am specifying the app platform, and I'm also specifying the ABI, which would be x86 or ARM. There's also an NDK toolchain version variable that you need to specify. And I then put my C and C++ wrapper files that I have to interface with the FFmpeg source code in my app JNI folder. And after I do this, I am running the ndk build command, which does its own magic and gives you this .so file. And you would place it in the JNI libs folder under the appropriate architecture in your project. So how do you interface with the .so library that you just built in your Android code? So for that, you have to write a Java wrapper class, which would load the module that you just built using the load library command. And it also defines all the native methods that you wrote in your C++ wrapper class in this file. And for that, it uses the native keyword. So I'm just going to show you a quick demo of the WeatherGIF app. This is using the .so method. And here I'm going to show when they share the WeatherGIF, it's executing all of that code that we just saw. And it overlays the icon as well as the text on top. It watermarks it into the video. So as you can see, it was taking about 8 to 10 seconds, which was reasonable. And in order to make it faster, I just reduced the video resolution and bitrate. And since it was GIFs, it was acceptable for my app because GIFs are not known to be very high quality anyway. So let's talk about the licensing issues with FFmpeg. FFmpeg is distributed under the LGPL license. That is the GNU Lesser General Public License, and it's distributed under the LGPL 2.1 or higher. It is unfortunately not available under any other licensing terms, even if you want to offer them money. So I went to the FFmpeg website and they had this really huge checklist, their license compliance checklist, which included about 18 points. And this is what it looked like to me, at least. Oops, sorry. And so I'm just going to talk about a few of these points which would affect your code and the process that we just discussed. So the first thing to note is that if you use enable GPL or enable non-free in your configure script, then your app will have to be distributed under the GPL license. So you will have to open source your code as well. So it's very important that you don't use these flags in the configure script unless you're just experimenting with it. Then the next thing to note is that since FFmpeg doesn't support H.264 encoding, the most popular library out there for H.264 is libx264, and that is distributed under the GPL license, unfortunately. But you can buy a commercial license to use it in your app if you wanted to sell your app in the Play Store. And with the commercial license, you can use the disable GPL flag when you build it, so that your app doesn't come under the GPL. Or what you could do is just use the other encoding formats like VP8 provided by Google, and those are free to use. And for the weather GIF app, since we were controlling the GIFs, the server was making sure that the files were in the VP8 format, and so I didn't have to deal with the H.264 encoding. And there's also the VP9 format, so you can decide which one to use. There is another point in the checklist which talks about dynamic linking. So you can only include FFmpeg as a dynamically linked library in your app. It cannot be statically linked. And you need to also distribute your FFmpeg source code, even if you don't make any changes to it. And include your configure script with the source code wherever you're making it public. This is an example of how Yelp declares that they are using FFmpeg in their app. So they put this line with their release notes every time they release their app on Google Play. Also, FFmpeg is very particular about using FFmpeg with 2 capital Fs. That is one of the points in their license compliance checklist. And if you're using FFmpeg, you also need to include the licenses in the folders that you have the binary or .so files. And this is what it looks like for the raw folder. So let's talk about what's good about FFmpeg. It's modular. You can control the different features that go into it and exclude the rest. It supports a lot of different codecs, although not the most popular ones, but it does have a wide variety of supported codecs. And it's very versatile. You can do just about any kind of video processing task with FFmpeg. There's also a lot of documentation sample code available since this library has been around for a while. What are some of the limitations that you encounter? The licensing is very tedious to follow. It's a bit slow. It's not the most performant when you use it in your Android app. And if you wanted to build a media player app or something like that, then if you were including a lot of different features of FFmpeg, it would be a really large binary. It comes to about 30 megabytes in size if you include all of its features. So I also looked at a few other libraries that I could use if I didn't have to do all of the operations like scaling and cropping on raw data. And I came across MP4 parser. Let's see what MP4 parser supports. It can do concatenation or merging of multiple files into a single file. The one thing to note here is that it only supports MP4 container format. So if you wanted to use it with other container formats, you could always use media codec, the native class, and do some kind of transcoding and convert the files to MP4 and then feed it to MP4 parser. It supports trimming of the video, so reducing the video in duration. And it also supports multiplexing as well as demultiplexing. This is just an example of how you could use the MP4 parser library in your app. Here I am concatenating a cropped version of the input with the entire input file. And as you can see, it's a really simple API to use. This is the RX Java version of the MP4 parser. And so let's see a demo of how performant this is. This is the Big Bug Bunny, This is the Big Bug Bunny video, which is a very popular benchmark for any kind of video processing research. It's a 30-second long file with a very high resolution as compared to the GIFs that I was using. And when I hit the concatenate video button, it's going to concatenate the cropped version of that file with the entire video that we just saw. So this is the cropped version, and then it starts the video from the beginning. So as you saw, that concatenation process and the cropping process was very fast with this library. So I just wanted to compare FFmpeg and MP4 parser in case you were trying to decide what to use in your app. So we saw that MP4 parser can do multiplexing and demultiplexing. It can do trimming and concatenation, but it doesn't have any encoding or decoding support. The one reason that it's a lot faster than FFmpeg is because it is not doing the encoding or decoding. It's just separating the container into the audio and the video streams, and it's operating on that data. So it doesn't have to do that extra step. And then FFmpeg supports scaling, cropping, and overlaying, all the things that I needed to do. But MP4 parser has no support for it. And then MP4 parser is a lot more easier to integrate because it's available as a Java library, and you don't need to do any kind of NDK building. And also the licensing terms for FFmpeg are kind of restrictive. It limits the codecs that you can use, and you have to look for other libraries that support encoding and decoding those formats. So that concludes the talk, and these are the resources that I use for my demos. And I just wanted to give thanks to the people here and the meetup groups, as well as Oanda for supporting me. And Oanda is a supporting sponsor for this conference today. They're also hiring. If you have any questions, now would be a great time to ask them. You can also find my talk at this GitHub link. And I do have some swag from Oanda for those of you who ask questions. So I have hats, and I also have power packs. I think I also have something else here. I have the car adapters for USB cables. Okay, great. Thank you very much for attending. And let me know if you have any feedback afterwards.